Because if they did, I could, yeah. You understand the world, I see, yes. I read a really interesting thing today about, it's called Peter's principle or something like that. It's the idea that if you're in a job and you're competent at your job, you'll be promoted. Okay? So what happens if you're not like competent? Like let's say you're just like a level of incompetent at your job. You just sit there, right? So what the idea was, hey, you three, stop, where are you going? Have you done your SES survey? Or you've been in, have you done your SES survey? Yes. If you do the survey today, you can get a chocolate. Gabriel's done so many surveys, he's got all the chocolates at the moment. Okay. So the idea is, get this. So the idea is that if you get promoted, right, you will eventually get promoted to the point where you're just at the right level of incompetent at your job that you won't be promoted again, right? So the whole world is just a balanced out, like people in a level where they're just incompetent at their job. Think about that.
Well, if you get promoted and your job becomes incompetent.
That's the only, like, that's the thing that doesn't, it's not considering though, is it? That some jobs actually, well then you get promoted at that job. Into the point you get into a job where you're incompetent and you don't get promoted.
But like the CEOs don't have to do as much as like...
Are you sure about that? You really think CEOs just sit around doing nothing?
I know rich people that do.
But are they CEOs?
Huh?
Are they CEOs or are they just shareholders?
For example, shareholders.
Yeah, but shareholding is not a job. Okay, assignment 2. This one's going to be a tight one because I want to give you guys as much time as possible for assignment 3. So this one's due. This one was due, I think it was the last week before the break. Yeah. Now, so this is where it gets interesting, okay? I'll be happy to put it due during the break, but if no one can have an extension on their final assignment. It's not possible. Okay? Because the date that the final assignment is due is literally just going to give me a short period of time to mark before the deadline for marks go in. Does that make sense? Cool? You know how it is. Yeah, okay. Actually, no, the final assignment's due week 13. And at week 12, you'll get a 2-week extension. Okay. Okay? Cool. Okay, so assignment 2. You will need to design a residence in response to a chosen client. So you guys get to choose something now instead of me forcing something upon you. And obviously the movie that you're dealing with, okay? If you want, you can have your client be directly related to the movie, or it doesn't have to be. The point of the client is that there's a specific thing that you have to deal with in your design, and each client's going to be they'll have their differences. I would like a 200 to 300 word statement. So the reason there isn't a poster this time is that each of these assignments is effectively a different set of outcomes. And so for this one, I would rather you not spend too much time on the communication side of it, purely because for this to work, you actually have to do a shit ton of work, and I'd rather we do a less work for the second assignment and more work for the third one, okay? So it's only 200 to 300 words to actually explain what it is, and then your Grasshopper script Rhino files all the supporting documents, okay? That's all we need. No presentation, drawings, nothing like that, unless I change my mind. So, the residence is a lot smaller than the cinema. It's between 80 and 120 square meters, and it is effectively probably going to be one of the most expensive apartments in Sydney, or houses, because it's in the Royal Botanic Gardens, and it's 2-bedroom. Crazy! So it needs a master bedroom, ensuite bathroom, a bedroom, a kitchen, dining, living, toilet and laundry. Now, an important thing about what I've seen with your cinemas is that a lot of you just focused on the building as if it were an object that just sat in space, okay? So there was very little work actually to make the inside of it function well, and the outcome of this really needs to work as a building, as a house, okay? You're grinning. You're looking forward to it. Yeah. So your clients. One of the 3 clients is a director, okay? And the specialty that a director will be asking for in their house is 100 square meters of surface area for storage. And this is, some of you may have heard me say I've half-assed this lecture. I should actually have images for this, but I don't. Okay, so what that means is you do not necessarily need to provide 100 square meters of floor area. That is not what I'm talking about. It's 100 square meters of space to store the director's film memorabilia. Films, like a library, okay? Or posters, or anything, okay? Anything that a director might actually care about the products that they've produced in the past, to store in a library or in literally just a museum. So it could be something that's quite systematic. So it uses the Dewey Decimal System and is sorted by alphabet, and they go and collect their films to play. Or it could be a jumble. I think Adam Savage has his, he's not a director, but why don't they just give you the link to the Google map? Come on.
What are you showing us again?
Adam Savage's movie memorabilia workshop, and you know Adam Savage from Mythbusters? So guys, some people really care about this stuff, and one day you might have a client that really cares about something that doesn't actually seem like it's worth anything. I work for people who care about sport for some reason. And I don't really care about it at all. So, just consider that it can be some, like, I think a lot of people get satisfaction out of libraries. You know, those giant libraries with just walls of books, and you know your OCD brain in the back of your head's telling you it's all sorted, everything is where it needs to be. Like there's some real attractive spaces that you can create, meta phenomenological spaces, more than just okay, that's where you store your films. Okay, so just consider that. Also, I know a lot of you have been playing around with the idea of height and verticality in your designs. Okay, so this can help. This particular client helps because it's a surface area, not a floor area problem. You can start incorporating this into that vertical surface area of your space. So just consider that. Cool? Okay. There is the writer. And writers are very interesting people. They're usually the actual driving creative force at the beginning of a film. And so they usually like to work in spaces that they have a lot of control over. So you'll need to provide 16 to 25 square meters of dynamic, changeable internal space, and also 16 to 25 square meters of adjacent external space to that internal space. And please consider privacy, okay? So external space needs to somehow be private. You don't want your writer to be a zoo exhibit for all the tourists that walk around the Royal Botanic Gardens, okay? So there's a little tidbit there. Writers sometimes work in groups, okay? So you might have a team that come together, and a lot of writers that work on TV, for example, do that. And try and create a space for the writer that they can control. So for example, I don't know, maybe a writer that's writing Alien actually wants to work in a really dark space that is dingy and actually makes them feel like they're in the space that they're writing. At the same time, that same writer might also be writing Little Miss Sunshine, right? And therefore, quite realistically, wants things to be sunny. And then the final client is a practical effects creator. So that would include like claymation animator, or like someone from Weta Workshop who actually does special effects. Okay? And for them, they will need a studio, which will be 35 to 50 square meters of open changeable space, which is 2 to 3 stories high. And I just thought it would be worth actually showing some of the types of spaces that these guys actually work with in reality. This thing doesn't have volume. So we've all probably seen claymation films. I think what we don't realize is how big they actually end up being. So that 35 to 50 square meters is a big space, okay? So, and it needs to be able to handle doing crazy things like making these claymation animation sets. I actually really like the guys that make these animations. They sort of show a lot of the back of house type stuff with the films, and it's like the outcomes are really good. And I'll show you I'll show a few more, because the sets that they're showing right now are rather small in comparison to their others. No, I don't want that. This guy is from the same film. Spoilers, sorry. So these sets are pretty big. What's funny?
So when we're actually shooting the film, we basically know what the movie is. And it does involve a little bit of film, the process of shooting the film is 2 years. The whole cycle, 5 years to 3. But by the time we start shooting, we basically know what this movie is. It might change a little bit on part, but it's not going to change. If you're going to tell a big, sweeping epic story, it has to look big and sweeping epic. You can't, which is sort of antithetical to how we make movies. I mean, essentially, the way you make a stop motion film is that you have a bunch of gussied up tabletops that you shoot in a big warehouse, and the idea of making that look like a big, majestic, endless, majestic vista is absurd. I mean, we talked about this movie as a stop motion David Lean film, which is kind of silly when you think about how you make these movies. I mean, the biggest set is maybe 20 feet, long, and so it was a real challenge to test the crew to make a film like this at this sweeping scale. And so we used basically every trick we had. It was one of the most challenging, most ambitious thing.
You can see each day when they change their top, the guy, the animator in the background, like their clothes change. That's like moves to the next day. So there's a scene in this with this giant skeleton thing. And you would think like, oh, okay, they'll just make a miniature version of it and make it look bigger, but it's actually massive. Look at it. So the thing is, a lot of people with practical effects in films now, they're going out of their way to make something extreme. And I'll show you a Weta Workshop video from Blade Runner 2049.
So essentially, we created this high-tech thing to move the torso around, but at the same time, it was like a marionette because we had these.
Cool. Okay. So, and then this video is awesome. So this is by Weta Workshop. They're based in Wellington. Has most of you have seen Blade Runner 2049? So there's a lot of practical effects. People are getting, there's a renaissance in practical effects. And before we continue, I want you to pay attention to the software that's being used on the computer screens, okay? Just pay attention to it. I want you guys to tell me what you see at the end, what you recognize.
The story, of course, was advanced. It's decades after the time of the original film. So Los Angeles has been built up a lot, and then LAPD, which is the newest of all the buildings, stands above all. It's the tallest building in town.
LA surrounding buildings, we've got about 37 48 scale, medium high detail buildings. Each building would probably take about a week to make.
Once they get approved, we run them through the previs and they calculate the scene, and then we start adding the details.
Stop it!
This makes us sad. The way LA is, it's all from underneath. It's this glowing, city light that you get to see because all these buildings are so big. You paint up these buildings being with their light.
All those things as a miniature is this giant composition of tiny little vignettes, tiny little stories, tiny little places all need to work together to make the whole miniature work. We call those existential crisis moments where graffiti would painted lots of little details like that. We've gone in and distressed some specific areas to make the building this whole look like it has that decay and that crazy weather from the Blade Runner world.
We are locking all the buildings in place with these boxes, so when we actually have the camera running through the building, everything lines up.
Pretty much each building has some fiber optic development. Or the preliminaries of a miniature build for a traction mesa, which is an enormous expanse of ruined technology. You really have to have the feeling that it really is rusty metal, that it really is crumbling and falling away.
Okay, shooting. 12 frames.
Yep, 12 frames confirmed.
Here's frame 20. Tilt and roll are kicking in.
It has all of the inherent flaws of building something. Real surfaces, illuminated with real light, with all the issues of tiny specular reflections.
The Waltz Tower, the bad guy's headquarters, that's 600th scale. In reality, it's about 3.5 kilometers tall.
At that scale, that measurement there as a human, up against these pieces of concrete, it's going to be a very tiny scale to work at.
So we have to find a method of surfacing them where you had the sense that you were seeing laid up stonework, even though you actually don't.
They're really bigatures. They're not miniatures. They're massive buildings. They're just stellar pieces of art.
There's a lot of Blade Runner in there. It's almost the thing we say when we look at the footage. Is it Blade Runner yet? Not quite. We have to tweak the light a little bit more, have to tweak the model a little bit more.
Yes, so it's supposed to be a sort of dark, stormy morning scene. Now to do that effect, the easiest way is to break down the shot into a series of elements. We shoot the skylight, we shoot the internal light, we shoot the lights of the little clearance light. Then when it's time to build the shot, you have complete control. You say, well, I want the red lights to be brighter. You can bring them up without changing anything else. So effectively, you're building a huge and very complicated sandwich that actually becomes the finished shot. There is a certain amount of magic when you just finished doing it, a shot. It took an hour and a half to shoot, and you see it there. It's existing, it has a soul to itself.
We've created a world in here in Little New Zealand on a
So-
miniature stage. It's really come together. It's gonna look up.
What software did you see? You saw SketchUp, did you? I didn't see any SketchUp. No, there was 3ds Max or Maya. They look very similar, and Rhino. Huh? Okay. A lot of animators like Maya. Yeah, they do. Yeah. So just be mindful that your physical effects user or creator is going to want to use that space to do some weird things, okay? So you got to provide them with a space that allows that, okay? Cool? So, it could be a workshop for them to build things. It could be somewhere they're actually going to create a shot like this. So provide them with that. So you don't have to pick one. You don't have to do all three. Only one. And that's assignment 2. Cool? Hooray, 20 minutes left. It's cool. So that, without actually having to go through all the images, actually saves me a lot of time. Excellent. So, I'm going to... Julia's not going to be here for a week or two, I think. She really doesn't like it when I do those Grasshopper scripting lessons in tutorial, because she just sits there and does nothing. Kind of like what Charlotte's doing now, right? So I'm going to take the opportunity while she's away to get a lot of them out of the way. Okay, so we're going to do a lot of Grasshopper in the tutorial, and we're going to start that off now with me explaining. Did you finish the survey?
Yeah, I did.
Good. With me explain. Did you finish the survey? They're good. Did you finish the survey? There you go.
Thank you.
Yeah, they're just coconut flavored crispy things. Okay. So, to sort of start this off, do you guys want to follow along or not? Okay. Ah, do you remember this? Huh? It's 1150, but as an elective for other classes. what should we start with? So, we did dispatch and weave a few weeks ago, right? Dispatch and weave is one way of using dispatch and weave is to do things with patterns, right? Where your pattern's true, false, and effectively it can split things apart and you can do things with them in a patterned-like fashion. So, there is another way of using it, and I believe you guys actually should all understand what this is because it's been taught to you already. Hold on to that. Okay, Zach's got a makeshift 6-sided dice. I'm going to test how smart you guys are. Okay. No, this isn't going to work. Yeah, this isn't going to... Everyone needs a dice for this. Okay, never mind. Okay, we've got a nice mix of genders. There's no gender fluid people here, right? No? Ollie? No? No gender fluid? Okay, excellent. We're not going to be ageist today. We're going to be sexist. Okay. I'm going to give you, guys, I'm going to give you a Boolean function, okay? With that Boolean function, the answer is either going to be true or false. Yeah? And if it is true, I want to put your arm up. Okay? And if it's false, I want you to do nothing. Actually, no, I want to put your arm out. Okay. You are female. Okay, arm up doesn't mean this. Arm up means this. Huh? You're true, yeah? Yeah. False, true. Okay. You are under the age of 18. $19. Okay. So, guys, you can put your arms down now. So, you've assessed the criteria. You've decided whether you've analysed yourself. You've checked out your genitalia or your chromosomes, and you've checked out your age. You know how old you are when you were born. You've tested that against my condition, right? And you've decided whether or not it's true or false, and then you go on to do something. So, am I repeating something that you've already been taught? I have. I am repeating it. I know I am. It's good? Okay. If condition, then function, else function. Okay? So, I'm male. Therefore, I've tested if I'm female, then do this function. But I'm not. So therefore, if I'm not female, I'm going to do this another function. So I put my arm out, okay? Is everyone familiar with this, please? You've done it with Python? Yes? Okay, good. So, how do we do this in Grasshopper? We don't know, right? No. Okay, so we can write operators that generate true and false values by analysing objects, okay? For example, I can measure the length of an object, therefore giving me a number, and then I can test that length if it's larger than another number or smaller, and that will then give me a true or false value for that line, okay? So, what can I do with true false values? What is a function? What is a component that I've got in Grasshopper that allows me to separate items by using a true and false value? Dispatch. Yeah. So, let's do it. I'm going to draw some lines. Actually, let's do this. I'm going to draw lines from these points. The way I'm going to do that is by using a partition list, which will then break each of these points into groups of 2. No. I refuse. No problem. And then, from that, I'm going to draw polylines. Drawing a list of lines, okay? Now, the important part of this in Grasshopper, or actually in any program, is the way that you generate the true and false. And a lot of that comes down to doing analysis. So, what can I analyze from a surface? Give me something that you could analyze from a surface. The what? Really? No. Like the material? I mean a NURB surface in Grasshopper. It's what? It's size. How do you describe size? It's volume. So like if it was closed, yeah, you could measure its volume. But what were you thinking? Surface area?
No, the length of
the length.
line, yeah.
Okay. Yeah, you could measure its length, like the length of its edges. How many sides do surfaces have? Right. So at least one of those has to have a length, right? Yeah, you could measure that. What else? Can you think? Yeah, like if there was a plane, if it was oriented a certain way. Yeah, you can do that. Guys, just as a reminder, every possible thing that you can do in Grasshopper is in the ribbon, okay? So if I go to surface, I can find under the analysis section all the analysis that I can do to surfaces. I swear this is out of focus. Okay, so what's one thing that you can test for a surface? Is planar. You can test if it's planar. Great, love it, right? So you remember all those surfaces that we generated last semester? You remember how we were going through and like forcing them to be planar so that we could laser cut them? We could actually test if they were planar to know if we needed to actually unwrap them or not using that component, okay? So everything that could be analyzed, such as we can analyze meshes, we can analyze curves, there should be an analysis section for that. And so for curves, we can test their curvature. We can test if they're closed. In this case, we're going to test their length. Okay, very simple one. And I'm just going to flatten the polyline list as it comes out, just to simplify this. And what we can see is we're getting a whole bunch of numbers. It looks like our average might be 10, okay? We'll go for 10. So let's write an operator that will give us a true false value. Everyone here is using expression, the function, the component. See? This guy? Okay, so in expression, we can write x times 2. And that'll take all the numbers and times it by 2, right? We can also write x is less than or greater than or less than and equal to or greater than and equal to or equals or doesn't equal, etc., 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 a number, and we could also use a variable like y to do that. So if x is less than y, what we can do is test that against a variable. And we'll set that to 20. And so what we'll get is a whole bunch of falses because none of our curves are less than 0.25. But as I ramp this up, this begins to generate a true and false value for each curve, okay? For each line, for each element, no matter what you're analyzing. So I've got a list of true and false values. Now what happens if I plug like a true and false, only 2 values into a dispatch, but I have 100 values going into the actual list? Dispatch effectively rolls over that like a pattern, right? So if I go true, false, then the next value will be true, and then that one after that will be false, true, false, true, false, true, false. But in this case, what we've done is we've just generated a list that is exactly the same length as the list that we are going to run the function on. So it doesn't need to repeat. So each individual true, false will be related to the item that it's dealing with, okay? So what that means is all the lines that I use to put, that I put into the L function here will come out true. So all the ones that are longer than 10 are going to be in my A list. And all the ones shorter than 10 are going to be in my B list. Or, sorry, that's the opposite. Everything that's shorter will be true. So these should be all the short ones, okay? Does that make sense? So what we've now done is we've created, in a way, the if. This part. Whatever we do to these curves now, once they've actually come out of the dispatch, is the then. So for example, if I take all the ones that come out of A and I do something to them, such as pipe them, so all the short ones we're going to pipe. Cool. So what I've done is I've said if less than C, then pipe. Else, let's extrude the ones that are long. What? No. So we're going to extrude the ones that are long. Ta-da! Right. And then if we want to bring them back together in the same list as before, like in the same order, so we've still got, you know, these are all in the same order as they once were, as one group, then what do we use? What? What? What do we use? What's the opposite of dispatch? Weave, right. So if we weave these back together, which ones were the extrude? What value did they have associated with them in the pattern? Huh? Which value? Were they true or false? False. So where would they go in the weave if we were to use the exact same pattern to bring them back together? 0. True, false equals 0, and therefore A, or true, equals 1. So this will bring them, and that needs to be flat. That will then create it'll bring your list back together and actually just create the completed if, then, else. Okay? It's that simple. And it's very powerful because you don't have to use else. Like your B's, you don't have to use them. Or you don't have to use your A's. They can just sit there and do nothing. And so you can start filtering out things, isolating things. So for example, you might randomly generate some stuff, but you only want the ones that are a certain size, or if they're planar, blah, 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 then do something to them. You could randomly generate true, false values to create glazing in a roof, for example. Or you could test whether or not a surface in a topology is of a certain steepness, and then if it is, then flatten it, etc., etc. So it's very useful. And just to demonstrate how it works, we can then slide from making them all extrusions through to making them all pipes. Cool? Does that make sense? So everyone understands if, then, and else, and then we can now do if, then, and else in Grasshopper. And that is one of the red functions that I expect in the checklist. So if you can use this in your design, you will get extra marks. Okay? Huh? Yes, I think it would be the very first red one in that list. Cool? Okay, we're going to talk about geometry pipelines in the tutorial. And it's going to blow your minds. You know what I'm talking about? Yeah. Okay.
I might know what it is, just not.
I warned the class not to sit far away. I warned them to come closer, but they're not coming closer, and now they're going to be able to hear me. I know, Eileen, I know you're charging, and you're just going to have to listen to this in the video when I put it up on YouTube. You'll be able to hear me. You just have to watch it on YouTube. I am speaking. I'm speaking. You'll get this when you watch the video, okay? You understand the joke. You're looking at me right now, like, what the fuck? But you'll get it when you watch the video. That's exactly what I said. That's exactly what I said. Everyone else is going to be watching this video being like, what's the point? Andrew's just talking to Arlene at the beginning of it. And so, hello to everyone else who's watching right now. Hi. Where is my grasshopper? Why doesn't it exist? Uh-oh.
知道我们做了个楼梯。他就做字幕点，他讲了30遍。
Fuck you.
1个小时过去了，我们干什么了
？Why? It must have ended yesterday. Fuck.
是我为什么看起来不是很脸？还胖了真的。
你跟他说啊，如果你胖，所以你看起来不懒。
他从来不觉得自己胖不胖，他建议跑哪我这意思。他也不是，我还是病上没有救我。
干什么呀？
是我这酷水播到上我的家。
It looks like shit.
You gonna spin it now?
Okay, I'm sorry, but this is
Okay. Huh? Yeah. But it's work. It's a work license. And they have like they have a checkout grace period. Yeah, I wish it didn't do that. Now I have to like plug it in every time I go to work. No. Like it's like, oh, you've checked out, but you can only check out for 2 weeks. Like, I want to be able to just have it. Go away.
对，真的，所以说这轻松这节课，不对，我不是。
Did that work? Yes! Sorry about that, everyone. Because this is going in the video. It's in the video. Right. Okay, let's do it. Hey, everybody. If you're not sitting close and you can't hear me, then it's your fault for not getting close when I told you to. Yavel is like, you gotta talk louder. Do you want me to talk louder, Yavel? Okay, guys, how's it going? I'm gonna introduce something to you that actually requires downloading something and installing a plugin for Grasshopper. So, the place where plugins for Grasshopper live is a website called foodforrhino.com. Let's go to foodforrhino.com. You know I love this class. Yes, I do. You know why they've been going extinct? It's because of all of the pufferfish drought in Africa. Now, guys, we're not going to be doing a, wow, that's it. Look at this fancy icon for rooster. Convert raster images to NURBS curve. Interesting. Okay. So there's a lot of plugins for Grasshopper, isn't there? There's a lot of plugins for Rhino as well. I want you to download all of them and install them. No, I'm joking. So I just want you to be very careful. I want you to be very careful when it comes to using plugins for Grasshopper. You have to consider that they're free normally, and you have to be a bit, sometimes you get hit and miss with free, right? Like if someone offered you a free chocolate, right? That chocolate could be very old chocolate, hence why it's free, yeah? Yeah, they're all cheap chocolate from yeah, exactly. No. So just be careful with free things, especially some of the plugins say they'll do something and they don't necessarily, you can't actually see how it works it out, and it might not be the actual appropriate way of doing it. So just be careful with that, okay? Cool? Especially with Lunchbox. This is being recorded, Billy. So is that why you're going to tune out? No. Okay, good. Okay, so the plugins that we want to download are called Human, Okay, and elephant. And or elephant. No, yeah. We'll be using human though. Not spelt elephant, elephant. I don't know why they called it that, but they did. Okay, so the reason we've... does everyone know how to download and install stuff for Grasshopper? Who said no? Okay, so if you go...
Andrew?
Yes?
You download the human and tree frog orders. Please download the human crowd tree frog orders.
You want... Guys, you want human for Rhino 6. Human for Rhino 6. If you're using Rhino 6, can those of my actual staff walk around and see if people are struggling to actually install the plugin? Thanks. Yeah. Yes? Okay, what's under that? What type of Rhino? Human for Rhino 6. So basically I ask you guys, stand up and walk around. Good job. You're helping. They know how to install plugins. We've already done plugins, Andrew. We already know Kangaroo. They're about no. They're about to be like, weep.
I was always down to do that tonight or tomorrow. I'm like using a plugin that simulates curve folding like instead of like.
Yeah, I know.
You know the one I'm talking about. Anyways.
I know exactly what you're doing.
Yeah, right. But I want to do it in Kangaroo instead because you can't see like what happens in each component that I want to do.
Right.
So then I'll like.
Good idea. Good thinking. Pardon?
I have a virtual machine. I'm finding it hard to find.
If you open Grasshopper, go File, Special Folders, select Components folder, and that will show you the folder where to put it.
Oh, I'm already.
You've already got human. Who got you to put human in?
Oh, no, I just I drag it in.
Ah.
I thought I haven't installed.
Okay. If you haven't caught up, if you're not there yet, who's done? Slow down. Seriously. Jeez. So one day, these guys, you'll be like, install this plugin. And it'll be like.
I feel like this always took like the longest part in class. Like, I'm like, you need a new plugin. And be like, oh, let's waste the next 45 minutes.
Yeah, exactly. The thing is, there is a vanilla version of this. Yeah, it's called Geometry Pipeline. You've never seen this? Okay. What is this? Ah, It's this component that we've never seen before.
文件发我呀。
哦，有道理。
Sorry, I didn't see your hand up.
就要 human 是。
human 和 animal。
那你装吗？这很多发我，怎么为什么？
Huh? Don't. It's shit. Yeah. You'll learn about this today, right now. Yeah. Okay, guys. Yeah. If you go, have you ever, so you've never installed a plugin before? So install plugins, usually you have to go File, Special Folders, Components folder, and that will show you the folder that you need to put your plugins.
Which one?
I have no idea. Just the top one.
Top one.
We might not use Elephant today. What do you have to do? You have to paste it into this folder. This folder. You can get to that folder. If you go to Grasshopper, if you go File, Special Folders, Components folder, that'll show the folder where to put it. No problem.
And then open up Grasshopper again.
Who's having trouble?
Me.
And then
Actually, it's confusing. We import this still. Yeah, so the or only this RHD.
那个文件也是刚。
Yeah, drag. Did you run it? Yeah, so
There should be a little human tab. What happened to your computer? It's a Mac. Is this a virtual machine? Are you running a virtual machine? Just restart it.
为什么不会烧死？为什么不会烧死？因为虚拟机更不红，真的不红，是超级不红。
You're right. You're right.
Yeah, VirtualBox is not useful.
Yeah, I agree. Yeah, bootcamp. It's all about bootcamp. Oh, actually, it'd be good if you guys get good.
We're good.
Get better. Get better. I need some Chinese speakers. Because we do work in China. And all over. Tianjin, Qingdao, Beijing, Hong Kong, Shenzhen. I'm just saying. I think Qingdao, Tianjin. We're doing the Maritime Museum in Tianjin. The National Maritime Museum of China.
National Museum?
National Maritime Museum of China. sea.
海洋博物馆。
海洋怎么念
MAR。
啊耶。The lecture you showed
哪个 lecture 秀了？
之前不来那个 lecture， 早上老弟不说那个早上这个。
There's a lot of there's going to be a lot of work in China doing this stuff. And if you know how to do this and you also know Chinese and English.
Yeah, my mom said in this domain, lack of people.
Huh?
The lack of people to do this.
They what?
Lack of people.
What does lack of mean?
Lack of.
Lack.
What does that mean?
Lack of.
What does it mean? Oh, there's a lack.
Yeah, lack.
What does your mum do?
Architect.
Yeah, there isn't many people that do this.
Yeah.
Okay, we there? We good? Okay, what I want you to do is open Rhino and Grasshopper and pull up under geometry pipeline. It's one of the only components that has a spiky left side. Well, spiky left side. And that's why it's shit. Now, you're going to be impressed with this, I know. Okay? But I just want you to consider that this is a shit component. And the better version of it is in human. Okay? But I just want to demonstrate what it is with the vanilla version of it. So this is the vanilla version. Okay? I'm going to delete that now. And we're going to go use humans version. So if I go to human, which is this one, and let's grab dynamic geometry pipeline. Much better because it's called dynamic. It's got dynamic in it. Okay? So, how have we grabbed geometry from Rhino and placed it into Grasshopper in the past?
Geometry.
We got to get a parameter, and then we place it into Grasshopper. Then we have to then go right click it, set one or set multiple, and then go pick those objects in order in Rhino to get that into Grasshopper. Okay? Dynamic geometry pipeline is a way of getting geometry into Grasshopper another way. Okay? So, what it does is it allows you to pick objects from your scene, from your Rhino file, by using selection filters, okay? So for example, if I go onto layer 1 and I draw a line, okay? In my dynamic geometry pipeline, if I type now layer 1 into a panel, it has to be exact, and I plug in, the type needs to pick up a curve. And I'll make these bigger for people to be able to read. Huh? You can read it now? Okay, so what we can see from the outcome of that is that it's now picked up that line-like curve, okay? So if I can now divide that just to make it obvious, we can see that that curve is now divided, yeah? So what does that mean? That means if I draw any curve now on layer 1, it immediately picks it up as part of that script. Okay? Wait a minute. Huh? What's your error say?
Solution exception, object reference not set.
01哦，它一定要一模一样，不然它找不到。然后好了，
嗯，
空格键。
我加空格的就行还是
Where's Branko?
C 是大写。
Does anyone get what I just did?
这么弱智的？
Huh? Your computer's much slower, so you don't realize? Are you there? Have you done this?
Oh.
What type of error does it say? Mouse over. Okay, guys. If you ever have an error in Grasshopper, you'll get this little bubble here. Mouse over it and it'll tell you what it says. What does it say? Huh? So they're not broken. So what do you mean? Have you drawn anything in Rhino yet? Okay, guys, I want you to go to the layer that we've written in. So I want you to go to layer 1, and I want you to draw a curve. Draw one. It could be anything. It could be a circle. Whoop. It could be a square. Whoop. The important thing here, guys, is there has to be something drawn in Rhino on that layer. If you haven't drawn it, it's not going to be able to pick it up. The computer is slow. You broke it?
You need a arrow 15.
Did he draw anything?
No, it didn't select layer 1.
Oh, okay.
It was on default. I had the same problem.
I'm surprised they're not impressed.
This is actually going to make things a lot easier to design.
We just, what do you mean? I just explained how to use geometry pipeline.
I've never used that.
Okay, if you grab dynamic geometry pipeline, you need to probably go explain this to Jamie, seeing as you just missed it. Then put in layer 1. So that means it's going to pick objects from layer 1.
All the curves?
And then it's going to pick all curves from layer 1. And then so if you draw curves in layer 1, watch. If I draw a curve on layer 1, it does the thing that we need it to do.
But is it just curves or can it be anything? The other one's going into what?
I've got that going into a divide curve, which is why it doesn't work.
With all due respect,
Because it's advanced. Let me... There's more. There's more. You'll see why it's advanced soon. Guys, are we all there? We all got it? Yeah? Do we understand why this is important? So why? Why, Louis? Huh? More options. Well, what that means is that you can write a script that runs whilst you draw. Okay? So what we're going to do is we're going to, look, we can actually use name as well. So you can actually name objects in Grasshopper. We can give them names, right? So what we're going to do, quite quickly, is we're going to grab the curves. So, by the way, if you just mouse over type, you can obviously, it's very small here, but you can actually pick points, curves, B-reps, meshes, hatches, extrusion, lights, text, blocks, and blocks. And if you want, you can type all and it will grab everything from that layer, not just curves, not just points, everything, okay? So, this is where it gets interesting. I'm gonna hit a few issues that I saw in assignment 1. A lot of you are we're trying to make plastic objects. Plastic being like you had to Boolean, like everything was getting Boolean together when it might not necessarily need to be Booleaned. Like for example, a hollow box, right? If you take a box like a cube in Rhino and then make a smaller cube and then try and cut that out of that bigger cube as just a hollow cube, it won't work, okay? So normally when we draw things in design, we draw them how they would be built. And so the ceiling and the walls aren't actually made of the same thing. They're actually made separate, almost like separate elements. We don't normally, like, obviously you can see the concrete blocks that make up these walls. We usually don't draw every single block. And Arlene's design's got a brick wall in it that literally has drawn every single brick. But that's because her wall actually needs to be drawn that way because the bricks are separated, right? It's not a solid wall. So we don't actually need to Boolean the ceiling and the floor and the walls together to make a single object. So today, what we're going to do is we're going to code a script that draws rooms based on curves that we draw in Rhino. And the rooms will create walls, slabs, and ceilings. It won't union them. And if we add more rooms, if we draw more curves, it'll add more rooms. Okay? So let's start by drawing at least 2 rooms. So just 2 rectangles. As long as we work with at least 2 things, normally our scripts can be robust. If we use just one, it breaks normally. When you want to do a second one and a third one and a fourth one. And what we want to do is bring those curves that we draw in whatever layer we choose into Grasshopper using the dynamic geometry pipeline. Cool. We're there. Should be pretty basic, right? So let's think about the various objects that these walls are going to create, these outlines. Let's start the way you would build a house. What comes first? Okay, which is another way of saying the floor. Okay, we're going to do the floor first, okay? So if this is the boundary of our room, then what is something that we can do to just describe a slab of concrete, let's say, assuming it's concrete. So we're just going to add thickness to it, right? Is it going to be flat? Is it planar? So let's create a boundary surface. Plug our room curves into that. And I'm going to make this 3D now. Pardon me. Cool? Okay, now let's give them thickness. We're going to extrude them, and we're going to extrude them down. So we're going to use a Z vector, unit Z, and we're going to plug a negative value into that. And I know that slabs generally are 150 to 200 mil deep. And this is actually going to quite quickly demonstrate that my scale is shit, because if I plug minus 200 into my unit Z, then bam, look at that. We get a huge thing, right? So what that means is these guys are too small. So I'm going to scale these up so that at least describes 4 meters. There we go. Wow, that's also... I selected my objects, I select scale. I then click a point I want to scale from. I then picked another point that I wanted to scale as a reference point. Once you do that, whatever number you type in will determine the actual length those 2 points are. So I picked those two and I said, I'm going to make that 4 meters, so 4,000 millimeters. Typed 4000, enter, which therefore makes it 4 meters long, giving me this nice, realistically sized room. Not a room for ants. What is this? A center for ants?
This is empty.
Do you have objects? Do you have curves drawn in Rhino? Can you? This mouse is massive.
我给他个1就好。对，我觉得1差不多。
你让你全部做完之后一起 scale 一样。
Ta-da! You just had an enter.
Okay. Oh.
Bling!
Thank you.
How you doing, Monica? Good. You're so far away. We all good? Guess what? We got slabs. Check it out. Okay, now what that means is if I want to add a new curve to the system, if I draw a curve, look at that. I got a slab. Slab. And if I pick them up and move them vertically, right? Because this is a process of learning. It's a process to learn. Okay? Huh? One more time. One more time. Let's do a circular slab. Yeah. Ah. Oh my god. So easy. Okay. So we're saving a few clicks, right? Yeah? We're good. We're good. Okay. So then, assuming like a ceiling is just the slab moved up, just let's forget that. Let's do some walls, right? So, how should we do these walls? What would you do as a wall in regards to these outer edges? There. Yep. Yep. So let's offset them. And we're going to offset that by a distance. So walls are generally between 100 mil and 300. If you want to go thicker, then you're doing that probably because your movie infers thick walls. Because most people don't do walls thicker than 300 normally.
Unless you have like a supercomputer you want to protect from like radiation.
No. You would do a different thing. You wouldn't do it with a wall. Yeah. So we'll go, that goes up to 300. Cool. And yeah, I get it. I know that this process is eventually going to create like a double thick wall between these two, but that's fine. We don't have to worry about it too much. So let's not have it go out. Let's have it go in. So I'm going to set the distance to an expression. Everyone's familiar with expressions. The expression we'll set is minus x. So that's now going in. Hey, Drew. I right-clicked set expression and I set it to minus x. That's set to 100. You know what? You can make that whatever you want. No problem. Okay, now, just be mindful, guys, that if you've got two curves touching in a boundary surface, sometimes it just makes them one curve, okay? So to isolate that, to stop that from happening, what we can do is graft the curve before it goes into the boundary surface, okay? What that's also going to do if we now graphed our curves coming out of the dynamic geometry pipeline, they're going to be in the same branch structure as our offset curve, okay? Which means that when we start working with these separately, start working on these with the exact same process, it isolates each curve, each branch into its own group, effectively, okay? So then, if we use these in its own boundary surface function, then it will ignore everything outside of its branch, but then create a boundary surface just between the outer curve and the inner curve, and not the outer curve, inner curve, and its neighbor, and its neighbor's neighbor, and its neighbor's neighbor's neighbor, okay? That becomes important when you do stuff like this, right? Because if these overlapped, then the boundary surface might want to relate to each other, so making them into their own branches helps. And we're going to do something even funkier soon. You guys are going to be surprised with this one. So, if we extrude this now in a positive fashion, not a negative one, it's going to go up. But as you'd notice, some rooms have a different height to others, and it's generally a good idea to actually play with different heights in rooms because, for example, I've asked you guys to choose a client, and you really should have already chosen. You should know in your head right now who it is. Is anyone interested in using the physical effects creator? Okay. What is the requirement of the physical effects creator's extra space? It needs to be 2 to 3 stories. So a nice, comfortable floor-to-floor height for most places is 3 meters. Okay, so there's my walls at 3 meters. Yeah? And this is already looking like an actual space, a building, huh? It's a home. Okay, so, but the thing is, let's say this is actually our creator's double height space, and not to say that you actually need, you can actually give us double height spaces for the other clients as well. They don't have to be just this, like the physical effects maker. What we're going to do is we're going to start pushing extra information from Rhino into Grasshopper, okay? So, in Rhino, if we select objects and we bring up either the layer or the properties tab, there are, now everyone's using Rhino 6. Who's using Rhino 5? Okay, I'm going to teach you how to do this for Rhino 5, but then I'm going to show everyone why Rhino 5's shit. Okay? And you'll realize why you need to go get Rhino 6. Okay. So, we can see on the object properties, there are all these properties here that are generally for its color, its layer, its line type, its print color, its print width. It's basically properties for printing. And a lot of CAD packages that we see nowadays, like AutoCAD and Rhino, are based in a culture that is obsessed with printing, okay? What you draw is what you print, and what you print is what you build, okay? But the industry is changing. Builders are starting to build things from a digital model, from not a PDF, not something that's printed on paper, from digital models. Some of you have actually experienced why having a digital model is very different to having a printed model. If I draw 100 lines all in the same space and I print them off, how many lines do I get on the paper? 1 line. Do I waste 100 times ink? Really? No. I only waste 1 times ink. Yeah? But if I drew 100 lines all in the same space, and I then told a laser cutter to print, how many times will it try and cut? 100 times, right? Yeah? So, digital models are changing. And the industry is changing, and people are actually trying to understand digital models more. And so instead of having a piece of text on a drawing that says, I am a bathroom, or I am a create a space, instead, we can actually store that information on the object. So in this case, we're going to store that information under the parameter name, okay? So after selecting both these curves, I'm going to type 5,000. It's properties, it's the little rainbow wheel. Yep, 5,000. My wife's nickname for cockroaches. 5,000. She doesn't like cockroaches because she's Japanese. They are, no. As in, a lot of Australians can just put up with cockroaches, right? There are some cultures and there are some people in those cultures that hate cockroaches so much that they won't even say the word cockroach. They'll come up with a nickname for them, in this case, 5,000. And the reason she calls them 5,000 is cockroaches in Japanese start with the syllable go, which also is the syllable for 5. And then she thinks that there's thousands of them, which is why she says 5,000. Yeah. It's very similar. It's in the same vein as why 4 is such a bad word in Chinese. Because 4 is also the same sound for the word death. And it's the same in Japanese. Huh? Does anyone here like the anime Bleach?
Yes.
Do you know Bleach? What are the gods of death called? Shinigami, meaning death gods. And so 4 is bad in Japanese, but even worse is 4-2. Yeah, 4-2 means death even more. But in Douglas Adams' Hitchhiker's Guide to the Galaxy, it's the answer to all life and everything. Sorry for nerding out, guys. Okay, we're back onto actual teaching Grasshopper. Where are we at? Okay, so has everyone typed 5,000 into their curves? What we're going to do is we're going to select one of them, one extra one, and change it from 5,000 to 3,000. Okay? So one of them, his name is 5,000. Nice to meet you, 5,000. Okay, you're 3,000. Nice to meet you, 3,000. Nice to meet you, 5,000. That's your name, okay? 3,000, 5,000, okay?
I see where you're going to go.
Okay. If I look at the script, is there anywhere I've typed one of those two numbers? Okay. Why? So what do those numbers represent, do you think? Yeah. They're potentially the height that we want those spaces to be. Okay? So, Human isn't just a plugin for pulling geometry into Grasshopper. It's also a plugin that can help us do other cool things, such as we can extract an object's attributes using object attributes. So if I quickly go and grab the geometry from a dynamic pipeline, and I grab a panel that describes the name, here we have 5,000 and 3,000. So if I just consider that I've got two branches with two trimmed surfaces, this particular one is probably going to relate to the first 5,000, And the second one is going to relate to the second 3,000. So what do we have to do to get this data into this data structure? No. No. What have we got? We've got a nice flat list, and we've got a list with branches. A single branch for each object. What do we have to do? Graft, okay? We're going to graft this list. So let's graft the data. And instead of using this panel, we're going to use the grafted data as the Z vector. And now our 5,000 room is 5,000 tall, and our 3,000 room is 3,000 tall. Yes? No difference. No, it's just visually. It's just visual. You can use either. So guys, just consider this now. If a curve that you've drawn doesn't have a name, it doesn't have walls, okay? Because those walls don't have a number to describe their height. It's null. So you need to select your curves and give them a name for them to have height. Okay? We're starting to see a new way of using Grasshopper.
Yes, Rhino is now
Huh?
Rhino is now useful.
Yeah, Rhino and Grasshopper work together, okay? Always work together. So, now this is cool in Rhino 5, but it's even epic in Rhino 6. So sorry, man. Sorry about that. Okay, so I don't want to name my room its height. Like, why name your room its height? That's silly, right? And what if you have other information that you want to store on the room? Like, you know, what if you actually want it to be named toilet or WC or master bedroom or creator space, right? So what we're going to do is, instead of storing those heights on the name, let's now select all of our curves, however many curves you've got, and just check this little tab over here. It's called Attribute User Text. Those of you using Rhino 5, you are not going to see this. It doesn't exist. This is something I asked for, and this is something they provided. Yay! Yay! No, I'm serious.
Did you actually ask them?
I was the only person that asked for this, and they added it to Rhino 6. And this particular thing in Rhino 6 actually effectively turns Rhino into a BIM package. And a lot of you you don't even know what BIM means, right? And one day you're gonna be like, Andrew, we hate it. We hate it so much. I just want you to remember that Rhino is BIM, okay? So the idea of BIM is building information modeling. All of you that are dealing with GIS right now, you're all playing around with GIS. BIM is just GIS, and all GIS is storing data on objects in space, okay? Geographic information system. It's just, you've got a point and it has a name and it has other things. It has data, like you might have a zone that describes how the average age of people that live in that area. In this case, we can have a room and have data stored on it, for example, whether or not it's a classroom, who the facilities management is, what the floor's made of, what type of paint the wall has. Charlotte literally spends her entire life now just providing content for BIM, which is exactly what I'm talking about, okay? So, instead of naming our rooms their height, let's create a new attribute text where the key is height and the value we can make is 5,000. So what we'll note is the names haven't changed, but we can see here under UDK and UDV, if I select UDK, that gives me a branch for each object, giving me a list of all of its user-defined keys. And there is a corresponding list with all the user-defined values. Cool? So let's go back to the properties, go back to the attribute user text, add a new one, and now in here I'm going to say use. And so for each of them, this one here is going to be, its use for me will be the creator space. The smaller one is going to be a WC. This one here is going to be the bedroom, let's say. Cool. So now in Grasshopper we can see that we've got height and use and 5,000 and creator space. Height and use 5,000 WC, height use 5,000 bedroom. Okay? Is that a question? What's the point?
叫 height 名字。
它有个属性是 height， 多了个属性叫 height。
Pardon?
就新建属性，它名字放哪？
You gotta write it.
height 就是名字啊。再新建一个。
So, these keys and values are extensible. This is an important word for coders. Extensible means you can add more, right? If you only see one, you can add another one. They can be 2. If you only see 4, they can be 10, okay? And you get to decide what they're called. It's up to you how your system is naming it. And this is kind of why BIM breaks some people's brains, because they'll go, oh yeah, the height is this. But another person might say, no, I would rather define height as an offset from a defined plane. And so you got to kind of work to a rule system. You got to be consistent, okay? So hence why working in teams in BIM is hard. But in this case, now that I've got 2 variables for each curve, how do I pick out the one that I want? We want to use the height for the extrusion, yeah? So how do I just isolate this number from each list? Yeah, so I could use list item 0, but what happens if it doesn't come in at that position? What if it comes in second?
You can split the list by 2.
But how do you know where it is? How would you know where it is? So, no, but the thing is, yes, we can look at the panel and go, ah, look, height is 0. So therefore we'll type 0 in. But at what situation could it change? It could change, right? And I know we've been kind of cheating in the past by actually just looking and typing 0 in. But now we're going to change our tact. We're going to get the computer to tell us which one height is and get the computer to choose that, okay? So I'm going to introduce some advanced set functions to you guys. And that function is, under set, it's called member index. And what member index does is if you plug a list into it and you tell it to go find an item, so for example, I want it to go find height, it will tell me the index of what height is in that list. For example, if I now type use in, what do you reckon it's going to give me, Branko? Which is 1. Okay, so if we type height, that's going to give us 0. So for example, if I actually remove a use from one of these curves, if use was 1, then that would go to 0 and that would be unique for that particular curve. I believe if I actually add ABC, oops, ABC var Oh, it's doing them in order. Okay, that's fun. It's literally doing them but in order. Yeah. The way you've added them. Yeah. Okay, either way, we've got item 0 now. So now if we use our list item, as you were correct, Vincent, then with our keys, if we pick out item 0, that'll give us the 5,000s there, okay? So now we don't actually have to graph this, and we can use the numbers coming from the list item to set the heights. So now instead of changing the name, we can change the object's height variable to 10,000, giving us 10 meters. Oh, that's big. Yeah. Cool? Happy? Okay, so what does this mean for some of the requirements in the checklist? I have a series of curves, each with a use, right? If I quickly grab the use, that's going to tell me exactly which room is where, right? Creator space, WC bedroom. If I quickly go grab that space's area using area, right? So let's take the inner face of the wall, so the one that's offset. So you can see by doing so we're getting center points. I can use display to display a text tag at the location of the center point, telling me the name of the room. And if I put in a reasonable size into that, such as 500, there we go. There's our creator space, there's our WC, and there's our bedroom. Yeah, it's kind of like that. Cool, we're there? Do you understand the use of this? Yes. Okay, can you have a... Did you say yes? You're doing a joke, my own joke to myself. Who needs help? Me! Oh, fuck you, Andrew. Okay, and we can justify that. We can actually justify that middle center. So you got a nice little...
Oh, what? Do that again.
You can right-click justify and then select middle center. Bastards. What? Why? Master. Oh, dude. This is nothing. This is nothing. Huh? I need my horn tooted as much as possible, yeah. Toot my horn, please. Branko's tooted my horn too much already. For the last 2 years. We've got an arrangement where he toots my horn and I'm satisfied. Okay. I love how much you care. Okay. So we've got to look at this. It's beautiful. Look at that. Now, what is something that would be very interesting to a homeowner? I know you're all very young and you're probably not going to go purchase a house in the next 30 years. Is what? The area. What area do we have? Now, look, we've already used area, right? We've already used area. So, what have we got? We've got the square millimeters, which is something that we don't like to think in. Huh? Real estate agent, here's my apartment in square millimeters. Okay, because Grasshopper isn't actually in any units, it only uses units in it uses units of your actual Rhino model, then what you will need to do is divide that area by a certain number. I'll tell you that number soon. Otherwise, there is actually in human, I believe. Yes, but then you have to draw everything in meters. This guy here is another little human component. It uses convert to unit document units. So if I say, give me something that is 5 meters long, and I plug that into this component, the outcome is going to give me 5,000. Okay? So if I typed 6 inches, it gives you that in millimeters. And the only use for this will actually just be typing 5 meters, because I can't imagine any of you actually typing anything in inches. I don't see any point to that whatsoever, unless you go overseas. Huh? Yeah. There's only 3 countries in the world that use it. No, sorry, 3.5. Okay. So what are we going to do? Does anyone actually know, off the top of their head, what I need to divide millimeters squared by to get meters squared? I love how you gave me the wrong answer. Yeah. Yeah, so how many millimeters? I know you gave me the right answer. How many millimeters in a meter? And so if you had a meter by a meter, what's that? Huh? It's 1,000 by 1,000. And so what's 1,000 by 1,000? 1 million. Okay? So there are 1 million square millimeters in a meter square. Yes, there is. There is. You don't believe me? Okay, fine. So what we need to do is convert our square millimeters into square meters. So we're going to use expression and just divide by 1 million, which is 6 zeros. 1, 2, 3, 4, 5, 6. Now, that's 10 million. Thank you very much. Another interesting tidbit, just to deviate. Even though we just shit on imperial inches, I hate inches. They're shit. But base 12 is actually a really cool number system. It's much smarter than base 10. Well, in base 10, it's harder to divide by 3 if you have a full number, right? But if I had 2 extra digits to our number system, that's 2 extra, we can still have decimal, but then 12 would be 10. Plus, also to just pull in, just to confirm with some of the Chinese students, is it similar to Japanese where when you get to 1,000, the next number beyond 1,000 is not 10,000, it's a new number. So for example, we go 1, 10, 100, 1,000, and then the next one is 10,000, and then 100,000. In Chinese and Japanese, they go 1, 10, 1,000. There's a new one. It's called man. And then the one after man is 10 man. Yeah. So what that means is, in the European English language, we put a comma every 3 numbers. That defines when we create new words for our numbers. But in the Asian cultures, they would put a comma every 4 numbers, every 4 zeros. And they don't do it. They're forced to do it our way. They put a comma every 3. but they should be putting every 4. 10,000 is actually blah, like it's 1 man. And then you get 10 man, 100 man, 1,000 man, and then you get the next one. Yeah. I'm so clever. Man is their word for 10,000. So their word for 1,000 is sen, right? So they don't say 10 sen. That would be like us saying 10,100. Yeah? Yeah, they're idiots. Okay, so we've divided by a million. I'm in a tangent mood today, it seems. It's fun though. Tangents are fun. Okay, so we've divided by a million, and that actually gives us our square meterage. Okay, so can anyone guess what this 37 square meters is relating to? Potentially, it is relating to what? And what about the toilet? How big is that? And we've got a rather big bedroom at 21 square meters, right? Okay, so do you remember one of the checklist items is scheduling? Right? Well, you could quite easily tell me in the next assignment that your spaces are of a certain square meterage. And how much is that total? If we add all of these up with a mass addition that's flattened, round it, and here's our total, 72. Huh? That's some new jokes. What did you say? How's that a joke? Huh? Oh, okay. Oh, okay. You're stupid. Cool? I didn't see that video. Cool? I know it seems boring now, but one day you're going to be like, oh, I'm so glad Andrew taught me that stuff. Cool? Okay, so shall we give this thing a ceiling? Huh? Cap it! Doesn't work. Shall we make windows? See, we actually know, you guys know how to put a ceiling on this, right? All you have to do is move the slab up by the height. Right? It's very easy, right? I'm not going to show that. Let's do windows. Windows? You want fireplace? Windows, 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 windows. Yeah, okay. Let's do windows. Sorry, man. This is going to be difficult. This is going to be really difficult. So, let's have a think about this for a sec. Let's do it manually. If I quickly grab my creator space, oh, I love this, it's so cool. And I snap it in, right? and I bake these elements. Oops. Let's just make sure not to bake that. Let's bake that on like another layer. Bake. Then typically you would actually use Boolean to probably put windows in, right? So all I have to do to draw a window is effectively draw a box that is the size of the window that I want, and use solid difference to cut that out. And and there's my hole in my wall, okay? But as we've probably, this is a very old school way of thinking about windows, okay? Because usually we make our windows now like the whole entire wall. So this whole facade is pretty much window. It's not actually like a hole cut in the wall, that is the wall. So, pardon? There's so many ways of doing this. Okay, what we're going to do, you guys are, you know, like you can make boxes and have them cut out, right? In Grasshopper, done. Okay, what we're going to do is choose options for not putting walls in and actually just leave the whole wall open so that we can put a facade. Or let's design the facade in Grasshopper. Yes, this is good. I like it. Okay, and this leads me to the final thing that we're going to do, which is baking. Proper baking. I want to learn this. Is that what you're saying? Okay. So, we're going to pick walls that aren't going to be walls. They're going to be facade. Okay? So, the way we're going to do that is with points. We'll grab points. We're going to have to create, we'll probably have to put them on a layer that isn't being used for something else. So, we'll create a layer and we'll call this facade points. You can call it whatever you want. Just copy whatever you've written, and that's what we're going to paste into a new geometry pipeline. Okay? So we're going to grab points from the facade points layer. Oh, geez, we can really fill out these classes, can't we? It's almost done. It's 5:10. Okay. I'm going to draw a point in the very center of the wall. So you can see I've drawn a point here in the center of the wall of the creator space. You can pick whichever wall you want. Yeah. I think I know how to do it without breaking people's brains. And we're going to use what we learnt today in the lecture. Who's flicking rubber bands? Oh, okay, is that a hair tie? It's a rubber band. Okay, so what we're going to do is we're going to use these points back up in the wall script. How come that's not reading it? By the way, guys, if you've got a point that's drawn on one layer and you want to, or something that's drawn on one layer and you want to move it to another, you just select it, right-click the layer that you want to move it to, and you can go change object layer, and that'll move it to that layer. Maybe. Well, that's one way of doing it. You have to pick the layer. Who? Rob? It might be an alias. Okay, so we're going to grab these points and we are going to use them here before they go into this whole mess. So what I'm going to do is just select all of this except for the actual dynamic geometry pipeline and slide it over to the right, because what we're going to do is we're going to work with this curve geometry as it comes out, okay? So as it comes out of the geometry pipeline, we need to explode it. Which is going to put it into branches for us, which is great. Then we are going to get the center points of each curve. If I reparameterize a curve, where is its center points parameter going to be? Zach? Excellent, love it. Do I need to stop asking that question now? Is it getting old? Did I hear a yes? Was that Michael? Yeah. It's getting old. 0.5. Okay, so what that's going to do is it's going to give us the center point of each edge of our rooms. And we are going to test whether or not that center point is close to any other of these points that we've drawn. Huh? Yeah, we're going to use closest point. Thanks, Branko. Now, this is where it gets really interesting, okay? For this to work, I don't understand that. This is so dumb. It's dumb. For this to work, no. This is FJMT building. No, Rob is from FJM. Rob used to work at FJMT. Yeah. He worked on it. That doesn't mean Cox worked on it. Rob would have worked on this building. It's not that old. It's not a Cox building, it's FJMT. No, it's not. It's right. Okay, maybe Rob didn't work on it. The point is, Cox didn't design this. There's no way Cox designed this. No, and I'm not talking about the quality of that connection. I know Cox buildings. This is not a Cox building. We just know, like, this isn't a Cox building. Yeah. Okay, either way, what we have to do is we actually have to move this into a data structure that is going to work for us, and it's going to be a little bit advanced, guys, and it requires a function called shift list. We're going to need to shift or trim the list. So I will explain what that is next week, because it is actually something that you need to understand that we haven't taught properly. So we're going to graft all our points so they're all in a grafted list, and we're going to make sure our points that are going to be facade points are all in a flat list. So we then need to plug these into our closest point system, and this will give us a list of distances, okay? What? Huh? So, from the lecture today, we need to test which one of these is at 0, right? Or at least like within a certain distance. So do you remember we created a function that does true falses? Yeah? So if we create a maths expression and we test x is smaller than y, or t, y, that means if we plug a slider into this, it's going to tell us which point is, let's go less than instead of larger than. It's going to tell us which one of these faces has the facade point on it, okay? So that's the one with true. So then if we dispatch our list of lines here using that, we need to just do this thing that I said, the shift list. So the one that you're probably going to have to use is this one. It's called shift paths. Is it really that boring? Okay. Huh? What was that, Billy? Okay. Be careful actually saying that you've got that, because there's actually people in this class that do. Yeah, I know, I'm telling Billy, yeah. I've got ADD. I've got ADD. Okay, so we want to shift the paths, and we'll just use the default shift, but what we're going to do is simplify that list, giving us the list per curve, okay? I'll explain this all next week. So what that means is, yes, when we plug that into the pattern of our dispatch and we dispatch the exploded curves, we get one line-like curve, which is the one that we want the facade on, and we get the rest as the ones that we want as walls, okay? So what we can do is join those ones that are walls back together, creating the lines, and we can then plug those now into the system that we've used to make walls, and that's broken it for some reason. Just remember, with this graph and the offset curve, just simplify them. That'll fix that problem up. Or it didn't. Why not? Ah, that's right. Shit. Okay, guys. Don't join them up. Plug them into the wall system. That will break the wall system, okay? Because what we've done is we've offsetted, but because the actual lines that make up the walls don't connect, they're not actually going to have, like, they're not going to create boundary surfaces because we've offset, but we haven't connected them. So just remember to do that. That's going to fuck everything up. Okay, for now, let's just make paper thin walls. Like so. Okay, and we're going to make, that works. Okay, so just we want to plug our dynamic geometry pipeline directly into the graph and the offset curve. So we're getting paper thin walls right now, and we'll deal with that next week when I explain all of these complex things. But the point being that we can now plug the B's out of our dispatch into the graphed tree, and they have that wall that doesn't necessarily need to, actually don't plug that into the graph tree, just plug that straight into the extrude. And we've now got that, the wall that was going to be the facade is no longer there, okay? So if I grab that point now and move it to another face, that now doesn't have a wall, yeah? So we're testing the distance that wall is away from the point, and if it's 0 or less than a certain number, then it is a facade, okay? And so we can then use that we can make a facade from that with A, or we can deal with that in Rhino. Does it make sense? Does it make sense? Yeah. Right, we've got somewhere. We did something basic, we did something intermediate, and we've done something rather advanced, okay? And I can see a lot of you have just stopped following along because I've gone too deep into the rabbit's den, okay? But that's good. That's a good lesson. Yeah, I like the fact that you can be like, oh, it's too hard. I'm out. Okay? So we're good. We've used dynamic geometry pipeline. It's very useful. It's very useful to do cool things like this. I want to work with landscape points. So do you remember we used Delaney to create landscapes? So if I just plug points into a Delaney, I can start using the layers with landscape. And if I start drawing points in, it will start creating a Delaney mesh where my points are. And I can start sculpting those points to start morphing that landscape to what I'd like it to be in a natural format. It's fast and quick. Yeah, it's fun. I can do whoop, whoop, whoop. Like this might be your actual contours, and you might go, I want to put a pyramid in here. Let's put in a pyramid. Whee! Pyramid. Done. Okay, cool. So there are so many uses for this. We would consider a person at Cox who actually understands how to use geometry pipelines as moving into advanced computational design. Okay? A lot of you, the fact that you can understand branches is a nice marker of that, but being able to use branches and geometry pipelines effectively defines you as being top-notch, okay? And there's a lot of people professionally that know neither of those two things, okay? So this is something that is worth learning. Creating twisty towers and really cool facades, that's great, but being able to write a script that can then apply that across multiple systems, or help people that don't know computational design create and design, and at the same time it gives them that information. That stuff is critical, world-breaking, pioneering stuff. Okay, so we've got about 30 minutes left. I reckon, what do you want to do? You just want to chill out? Have a chat? Yeah? This is pretty full on, right? It feels like you're all quite worn out. Is that because of the assignment? Okay. Okay. Yes? The script, the videos.